Hello everyone. In this lesson, I will solve the questions of test prep of chapter 2. Use the function f of x equal to piecewise function 2 minus x when x less than or equal 1, x over 2 plus 1 when x greater than 1 to solve questions number 1 to 4. Find the limit of the function when x approach to 1 from left. X approach to 1 from left, it means x less than 1. Substitute 1 in this segment equal to limit 2 minus x when x approach to 1 from left equal to 2 minus 1 equal to 1. The right choice is C. Limit f of x when x approach to 1, number 2. Limit f of x when x approach to 1 from right. From right it means x greater than 1. Then this limit will be x approach to 1 from right. Substitute in the second segment equal to 1 over 2 plus 1 equal to 3 over 2. Choice B. Number 3, limit of f of x when x approach to 1. Since the limit from left not equal to the limit from right, then the limit does not exist. F of 1, substitute in the first segment since equal is in the first segment. F of 1 equal to 2 minus 1 equal to 1. Question number 5. Find the limit of x over x minus 2 when x approach to 2 from left. This 2 is not in the domain of this segment on this function, so the answer is either infinity or negative infinity. Because I cannot simplify this function, I cannot find this limit, so I substitute directly. X less approach to 2 from left, it means x less than 2. I substitute every x with 1.5, so the answer will be positive over negative equal to negative infinity. Choice A. Limit x approach to 0, cosine 2x over x, also 0 is not in the domain of this function. I cannot simplify or do anything with it, so I will substitute directly. Cosine 2 times 0 over 0 equal 1 over 0 equal does not exist. Choice D. Question number 7. Limit sine 3x over x when x approach to 0. Multiply this limit by 3 and divide by 3, so I can use the rule of trigonometric function. This limit equal to 1, 3 times 1, 3. The right choice is B. Over which interval f of x equal 1 over square root x have points of discontinuity. This function have point of discontinuity when x less than or equal 0. Less than or equal 0, it means negative infinity, open interval to 0 with 0. Choice B. Since the square root is in the denominator, which is not point of discontinuity of this point. Which is not point, negative 1 is point of discontinuity. 0 also is point of discontinuity. 1/2 is also point of discontinuity, but x equal 1, 1 minus 1, 0, square root 0 is 0. The function is defined. If I want to find the interval that the function is defined, I set x minus 1 greater than or equal 0, then x greater than or equal 1, then the interval is 1 to positive infinity, then negative 1 not in the function, 0 not in this function, negative 1 half not in this interval, 1 is within this interval, so the right choice is x equal 1. Question number 10, which is false statement corresponding to this function? F of x equal 2x when x between 0 and 1, 1 when x equal 1, negative x plus a 3 when x between 1 and 2. F of 1 is not defined. When x equal 1, the function is 1, so this statement is false. Limit f of x when x approach to 0 from right exists. 0 from right, which means x greater than 0. 2 times 0, 0 exists. This statement is true. Limit f of x when x approach to 2 from left does not exist. 2 from left, it means when x less than 2. Substitute in this segment, negative 2 plus a 3, 1. It is exists. It is wrong statement. Limit f of x when x approach to 1 does not exist. When x approach to 1 from left, it is 2. From right, also it is 2. So also this statement is wrong. It is exist. It is equal to. Limit f of x when x approach to 1 not equal to f of 1. F of 1 is 1 and the limit is 2. This statement is true. So I think that this question contained wrong. There is 2 statements true and 3 wrong. Number 11, which is not removable point of discontinuity of this function. Rewrite this function as f of x equal to, reduce x minus what? X minus 1, x plus 1 square with x plus 1 square, x minus 2 with x minus 2, still we have x minus 2 here, x with x minus 3 power 2 with x minus 3 cube, still x minus 3. The point of removable discontinuity, the point of discontinuity of this function is a 3 and it is not removable. So the right choice is the last one. Number 12, which is false statement corresponding to this function. Limit f of x when x approach to 4 exists. When x approach to 4 from left, it is a 3. When x approach to 4 from right, it is negative 4 plus 7, also 3. So this statement is true. F of 4 exists. F of 4, when x equals 4, the function is 2. Also this is true. Limit f of x when x approach to 6 exists. When x approach to 6 from left, negative 6 plus 7, 1. From right, also it is 1. So this statement is also true. Limit f of x when x approach to 8 from left exists. It is 1. Exists when x less than 8. F of x is not continuous at x equal 4. F of 4 equal to 2. And the limit is 3. So this statement is wrong. The function is not continuous, is discontinuous at x equal 4. Question number 13, which is tangent line, which of this equation is the equation of the tangent line to the graph of the function 9 minus x squared at x equal 2. This question is from chapter 3. Let us solve it. Find the point of tangency first. Substitute 2 in the function to find the y coordinate. F of 2 equal to 9 minus 2 squared equal to 9 minus 4 equal to 5. So the point of discontinuity is 2, 5. To find the equation of the tangent line, we need the slope. I'll use the derivative of this function to find the slope. F prime of x equal to negative 2x. Then f prime at the point of tangency of 2 equal to negative 2 times 2 equal to negative 4. Now I have the slope and I have the point of tangency. Apply the slope point formula to find the equation of tangency. Y minus y1 equals slope x minus x1, y minus 5 equal to negative 4 times x minus 2 equal y equal to negative 4x plus 8 plus 5 equal y equal to negative 4x plus 13. The right choice is B. Question number 14. The functions below are defined for all x except for x equals 0. Which one can redefine to be continuous at x equals 0? It means which function has a removable discontinuity at 0, which function has a limit when x approaches to 0. This function has no, the first function and the second function has no limit when x approaches to 0. They are oscillating when x approaches to 0. Also, the last function, cosine x over sine x, is cotan x. It is goes to negative infinity when x approaches to 0 from left and to positive infinity when x approaches to 0 from right. Except this function, the limit of tan x over x when x approaches to 0 equals 1. Since the limit exists, then we can redefine this function as tan x over x when x not equal to 0, 1 when x equal to 0. Now f of 0 is 1, the limit also is 1, the function is continuous. The right choice is C. Question number 15. F of x equal piecewise function defined as you see. For which value of a does f of x became continuous over negative infinity to positive infinity? Check the limit should be exist when x approaches to negative 1. The limit when x approaches to negative 1 from left when x less than negative 1, the segment is x power 2 plus a equal to negative 1 power 2 plus a equal to 1 plus a. And the limit when x approaches to negative 1 from right when x greater than negative 1, the segment is x cubed minus 8 equal to negative 1 cube minus 8 equal to negative 1, negative 8 equal to negative 9. Now, the value of the limit from left should be equal to the limit from right. 1 plus a equal to negative 9. So a equal to negative 10. Choice D. See you next lesson.